All right, so good evening, everyone. In this evening session, we're going to take a look at simultaneous equations. This here is part 2. So if you did not watch the first part, please go over it and make sure that we understand each of the substitution and the elimination method. Now remember, a simultaneous equation has two unknowns, right? And you're trying to solve for both those unknowns in the same question. They could give us certain worded problems as well. So let's take a look. 4 mangoes and 2 pears cost $24, while 2 mangoes and 3 pears cost $16. Write a pair of simultaneous equations in X and Y to represent the given information. State clearly what the X and the Y represent, and by solving the pair of equations, determine the cost of both fruits. Now, sometimes they'll tell you what is X and what is Y. If they don't, you select or you choose which is which. Right? So let's say X is the cost of 1 mango. And let's say Y is the cost of 1 pear. Right? Those are the things we're looking for. We're looking for the cost of a mango and the cost of a pear. You could have done it the other way around and say Y is the cost of the mango and X is the cost of the pear. Once you let them know clearly which is which, that's what we have to do. So they said 4 mangoes. So the cost of 4 mangoes will be 4 times the cost of 1 mango. So that will be 4x. And in mathematics, we add 2 pairs. The cost of 1 pair is y. So if we have two of them, it will be 2y is equal to 24. And then 2 mangoes, so that's 2x, and 3 pairs is equal to $16. So using the information, you write your simultaneous equations. Right, so first step is we label our equations 1 and 2. Now remember, we have 2 pairs of unknowns. We have a pair of X and a pair of Y's. Now your goal is to make one of those pairs 0. So the only way to make them 0 is if we make them the same, and then we can add or subtract them to make them 0. Miss, how you could add to make it 0? That's like if you have 4 and -4. If I want to make this 0, I cannot subtract because minus minus becomes a plus, and this becomes 4 plus 4, which is 8. So in order to make it 0, I actually have to add them. So when I add them, this is replaced with minus. So 4 minus 4 would be 0. So that's what I mean by either we add them depending on the signs or subtract them to get 0. So to make it easier, I can make these two the same. The LCM of 4 and 2 is 4. So I can make this 4 by multiplying everything by 2. So you tell them what you're doing. Right? So you tell them that you're going to multiply all of equation 2 by the number 2. Right? So you label it and you let us know what you're doing. So 2 2s are 4x, 3 2s are 6y is equal to 16 times 2, which is 32. So we just generated a new equation. It's called an equivalent equation. So we're going to label this equation 3. Now we generated that equation in order to wait for the other one, which has 4x. Now, in order to make this 0, now that they're the same, we could subtract them. So 4x minus 4x, that's 0. Whatever you did to make it 0, you have to do it throughout. So we now subtract the y's. 6y, take away 2y, that's 4y. And then 32 minus 24 is 8. So we end up with 4y is equal to 8. So we could solve. Once you cross the equal sign, it will be opposite operation. So it becomes 8 divided by 4. So y is 2. Now that you found the value of y, you're going to substitute it into one of the original equations. Right, so you either substitute it into equation 1 or 2, not the new ones generated. So wherever we have y, we're going to replace it with 2. Right, so we're going to solve for x now. 4x plus 2 2s, that's 4, is equal to 24. Carry across your equal sign. Remember, once you cross the equal sign, we do the opposite operation. So this becomes 4x is equal to 24 minus 4. 4x will be 20. The 4 there was multiplied. So once it crosses the equal sign, the opposite will be dividing. So we get x. X is 20 divided by 4, which is 5. Now, we know the value of x and we know the value of y. But they never asked you for x and y. They asked us, what's the cost of a pear and the cost of a mango? So, we know that x is equal to the cost of mango and x is 5. So the cost of a mango is $5. And y is equal to cost of a pear and y is $2. So you make sure your last line is telling you what is the value of x and what is the value of y. All right. Remember, with simultaneous equations, you could always check back. You don't have to show this step. So x is 5, y is 2. Substitute it and check it back into equation 2. 5 2s, that's 10. 3 2s are 6. So 10 plus 6 is 16. So once it works back, you know that you are correct. If it doesn't, it means you made an error. And you just have to check back your working. All right, so this one is taken from the June 2018. It says statement 1. 2 adult tickets and 3 children tickets cost $43. Statement 2. 1 adult ticket and 1 child ticket cost $18.50. They said, let X. So they told you what they wanted X to represent. The cost of 1 adult ticket. Right? So if they told you, you use what they are looking for. Right? So cost of adult tickets is X dollars. And Y is the cost of a child ticket. Right, so they said 2 adult tickets. So if we have 2 adult tickets and the cost for those 2 will be 2 times X. And 3 children tickets, that's 3 times Y, is equal to $43. And then they said 1 adult ticket, which is X. Remember, we don't have to put a 1 because it's understood. And 1 ticket for a child, that's 1Y, is equal to $18.50. It says, write the 2 equations in X and Y to represent the information above. Right, so this is it. So this is part 1. And then they said, solve the equations to determine the cost of an adult ticket. Now, because we have 2 unknowns in one question, we know that it is a simultaneous equation. In order to solve a simultaneous equation, remember your first step is to make one of the pairs the same number. Right? So either make the x's the same or the y's the same, it doesn't matter. Right? So make one pair of the unknowns the same. Right? Now, I could make the y's the same by multiplying all of equation 2 by the number 3. Or I could make the x's the same by multiplying all of equation 2 by the number 2. So I'm going to make the x's the same. So all of equation 2, I'll multiply by the number 2. So I let them know what we're doing. Multiply equation 2 by 2. Notice it's not no long statements, right? So you know MULT means to multiply equation 2 by the number 2. So everything in equation 2, we're going to multiply by 2. So 2 times x is 2x. 2 times y is 2y is equal to 1850 times 2. I am using my calculator as well. And I got that to be 37. So we generated a new equation. So I'll label it equation 3. Right, so you make one pair the same if they are not already the same. Right, so these notes would have been given in the last class, so you don't have to write it again. So if they aren't already the same, we make it the same. Then decide whether you subtract them.
Excuse me, Miss I'm not seeing any thing where you're writing on top.
Right, so we decide whether you subtract or add to eliminate that pair of unknowns. Right, so the pair that you made the same, you either add them or subtract them depending on the signs. Right, so you decide, okay, would I get 0 if I add them? Or if I subtract them, I'll get 0. So decide whether you add or subtract to eliminate that pair of unknowns. Right, so I made this the same in order to work with equation 1. So I'm putting equation 1 back on top of here. So now my equations, my x's are the same. Now, in order to make 0 here, I'll have to subtract 2x, take away 2x is 0. Now, whatever you did to make that 0, you have to perform that operation throughout. So if you added, you have to add all the others, meaning you have to add this, this, this. If we subtract it to get 0, you subtract them. So perform that operation throughout. Right, so we also have to subtract these. So 3y, take away 2y, that's like 3 mangoes, take away 2 mangoes, that's 1 mango or 1y. But we do not have to put the 1 because it's understood. And then 43, take away 27, 43, take away 27, remember use a calculator to make it easier. I got 16. So I got, no, not 16. I put 27 instead of 37. Right, so 43 minus 37 I got 6. So I got that the value of y is equal to 6. After you found the value of one of the unknowns, your next step is you're going to substitute that value. Well, in fact, solve for that letter. So you're going to basically solve for the remaining unknown. So solve for the remaining unknown. Once you do, we're then going to substitute. I'll put sub for substitute the value from step 3 into equation 1 or 2. So you substitute y into either equation 1 or 2. For some reason, I always put it into equation 1. So you let them know. Sub y is equal to 6 into, and you let them know which one you are substituting it into. I, for habit, always place it into equation 1. So wherever I have y, I'll replace it with 6. Right, so we replace it with 6. And then we solve for the other unknown. So that's step 5. Solve for other unknown. So carry across. Once you cross equal sign, you perform the opposite operation. So we have 43 minus 18. I got 25. And then if 2x is equal to 25, we want to find out for 1x. So it was attached to the x through multiplication. So when it goes across, you'll divide. 25 divided by 2. I got 12.5, which is basically, as money, $12.50. Now, they asked you for the cost of an adult ticket. The adult ticket is X. So X, so this is your answer. X is equal to cost of adult tickets and it's equal to $12.50. Now, if you want to check and see if your answers are correct, we could sub it back into the next equation that you didn't use before. Right, so if X is 12.50 and Y was 6, 12.50 plus 6 is 18.50. So you know that your answer is correct. And that's it. All right, so let's take a look at this question. Now, this question involves inequalities. Now, let's just recap inequalities to make sure that we understand. All right, so an inequality is simply whereby an equation is not exactly equal to. So we might see these symbols. We might see this sign or this sign, or this sign or this sign. Now, a lot of people, they mix up which one is greater than and which one is less than. Now, the easiest way for you to remember is that these inequality signs, think of them as an alligator mouth. I know we're going back a bit to primary school, but once you understand it from that, there's no mixing up. So think of it as an alligator mouth. And basically, your alligator mouth opens to the bigger number. So if we have 5 and 10, 10 is bigger, so your alligator mouth will be open towards the 10. So in other words, this is telling us 5 is less than 10, or 10 is greater than 5. If I was given 16 and 3, 16 is bigger than 3, so Ali the gator would bite the 16 and not the 3. So that's one way to know what those symbols are telling you. The side with the mouth is always facing the bigger number, or the bigger of the two expressions. Now, these signs would be greater than and less than, but they are not inclusive. Right, so this here would be your greater than and your less than signs. It does not include the number. So like if I say X is greater than 5, it means that X could be from the set of numbers bigger than 5. So it could be 6, 7, 8, 9, 10, and so on, all the way up to infinity. But it does not include 5. If I have X is less than 5, it means that the numbers or the solutions for X could be 4, 3, 2, 1, 0, -1, -2, and so on, all the way to negative infinity. But it does not include 5. These, on the other hand, they are inclusive. Right, so this one will be less than or equal to this one will be greater than or equal to. So it means that this includes the number, so they are inclusive. So what this means is that if x is greater than or equal to 5, it could be 5, 6, 7, 8, 9, all the way up to positive infinity. But it includes 5 in its set. And if x is less than or equal to 5, it means that x could be from 5, 4, 3, 2, 1, all the way to negative infinity. So remember, this is not inclusive. It doesn't include the number itself, but these are inclusive. All right. So we understand these. Now, what we need to understand is that just like a regular algebraic sum, so let's say they gave you 2x plus 6 is equal to 10. Like a regular algebraic sum with an equal sign, we could solve for this. So we have 2x carry across. Once you cross the sign, you do the opposite operation. So this becomes minus 6. 2x is equal to 10 minus 6, which is 4. Carry this across, x is 4 divided by 2, x is 2. So just how we would solve a regular algebraic equation, we could solve an algebraic inequality. And an algebraic inequality simply means instead of an equal sign, they have one of these inequality signs, right? So when you're solving it as though it's a regular inequality, algebraic equation. Right? So we solve it the same way. You carry across the sign. Once you cross the sign, you do the opposite operation. So we end up with 2x is greater than or equal to 10 minus 6, which is 4. I want x alone, so carry across just as you do a normal equation. Once you cross, you do the opposite operation. So we end up with x is greater than or equal to 4 divided by 2, which is 2. And what this means is that the values of x is greater than or equal to 2. So if they ask us to represent the solution as a set, then x is going to be from the set of it's bigger than or equal to 2. So it could be 2, 3, 4, 5, and so on. But it includes 2. Right? So it just means that the value of x could be 2, 3, 4, 5, 6, or any other number. So we solve them just the way we'll solve regular algebraic equations. Let's say they ask you to represent it on a number line. Right? So let's say they ask you to represent this answer on a number line. Right? So if they ask you represent the answer on a number line, you know your number line has positive and negative numbers. What you do is on your number line, you just want to represent the numbers that you have. So it's around 2. So you go up a bit and you go down a bit, right? Because you don't want to draw a whole length of the number line. You're just drawing around the number, right? So you go up a bit and you go down a bit. Now on your number line, when you're drawing it, an empty circle means not inclusive, right? Which means you use it for these signs. Right, so if it's these, we use an empty circle. If it's these, where they're inclusive, we use a circle and it shaded it. This means inclusive. Now, if I had to represent this, this is telling me x is greater than or equal to 2. So it's inclusive, so whereby I have 2, because it's greater than or equal to, I'm going to shade it in and draw the arrow in the direction where I could find the answer. So it's bigger than 2, so I draw my arrow to the right because the numbers to the right is bigger than 2. Example, look, they gave us one like this in John 20:18. It says, solve the inequality 3 minus 2x is greater than 5. Remember, when you're solving, you solve it like if there was an equal sign. Right, so treat it as just like a normal equal sign, but instead you have your inequality sign. So let's start with the 3. You carry across everything. And once you cross the equal sign, you do the opposite operation. Remember, this negative sign belongs to the 2x. So this was actually added. So when it goes across, it becomes minus. So we have 5 minus 3. So we have 2x is greater than 5 minus 3, which is 2. Now, normally, our inequality sign stays in the same direction. Note, the only time, I'm writing a short note on the right-hand side, the only time your inequality sign changes direction meaning to change from this to this, or vice versa, meaning the other way around, or from this to this, or vice versa, is when we divide by a negative number. right? So that's the only time your inequality sign will flip to the opposite direction, right? It will not flip just so unless you divide by a negative number. So look at this. I have negative 2 here. When I carry this across, this negative 2 was multiplying. So when it goes across, you're going to be dividing. So I'll be dividing by a negative number. And once you divide by a negative number, your sign will flip direction. So 2 divided by negative 2 is negative 1. Right? So that's a rule. The only time it flips is if we divide by a negative number. Otherwise, it stays the same. And then they asked us, represent your answer on a number line. So we have negative 1. Now, it's this one, which means it's not inclusive. So you're using an empty circle. And it's saying that x is less than negative 1. So if it's less than, it means that the direction of the numbers will be coming from the left to it. So you draw an arrow in the direction. Some books and some teachers, they'll draw it on the number line itself. But I normally do it above. Right? So if your teacher wants you to do it on the line itself, yes, you could do it, but I usually do it above. All right, so pausing here.